right. And then I need to present my screen, a window. This window, share. Good morning. All right. And there's another. Here we go. So I just started recording, and just to make sure you're all aware, I record the screen, a different screen from what you're on. I have a 2-monitor setup, and I record. I don't record your little image or anything you might enter into the chat. That's all separate. So, and it doesn't pick up your audio. So if you say something out loud, the microphone or the recording system does not pick that up either. So there you go. Today, 30 minutes live stuff. We'll go through some notes with some demonstration stuff. We'll get started on the assignment. Some of you might have already started. I didn't take a look. I think the assignment is a pretty fun sort of a deal, honestly, truly. It can be fun. Like frustrating, but fun. If you let yourself have fun, you will. After the live class, maybe another 30 minutes if you need it to finish up that assignment. And there you go. Good morning. And same as always, if you have questions, email, message me from Google Classroom. You can use the resource to set up a Google Meet if you would like. So there we go. All right. The classwork section has a little bit of notes. So that's where I'm going to go right now. I'm going to make this a little bit smaller because I'm not used to that view right now. So we'll go through some of the notes. There's this note sheet that's attached that is the same as the note sheet that was attached last week. You don't have to use that. You don't have to at all, but it's just something that I'm providing because sometimes it's nice to have that structure. When we were in face-to-face sort of mode in the before days, in the before COVID days, I gave everybody those note sheets, and then you could, whatever you recorded there, you could use on the quizzes and the tests. Because, you know, in science, we use lab notebooks, we record notes, and we refer to them. So it seems kind of foolish to not be able to refer to your notes. I'm babbling. Thanks for putting up with me. So that copy is there. You don't have to use it. We're continuing on that. So we've filled in some of that last week. We'll do a smidge bit more today. So clicking on that. Hide that. There we go. And I'm going to move that over here. And this I thought was really, I didn't know about this before. I've never had really reason to use it. If I click on presenter view, and then, come on. There's a way where you can ask questions anonymously. So if we're going through something and it doesn't make any sense at all, you can click on this link if it shows up. Good Lord. Here we go. So now I can do audience tools. Start new. On. There we go. So now, this link, I will copy link address. So that link I'm putting in the chat for our Google meeting. And then if you have a question, let's see, where did that go? There it is. So now you should be able to click on that. Let's see, I'll see if I'll try to share it so you can see what would happen. Come on now. Okay, so here, that just keeps on going. So if I say, what's the deal? Whatever the question is, once I click or you click, so I'm showing this is what you would see if you click on the link that was sent in the Google Meet. If you type in a question and you say ask anonymously, and then you hit submit, you do have to, if you want it to be anonymous, you have to click on that little box, ask anonymously, submit. Then everybody just sees that. Your classmates don't know who said that, and honestly, I don't know who said that. I just know that there's a question. So, there should be. So if anything comes up while we're going through and doing this and you wonder what the bejeezers, you can put there what your bejeezers questions in that anonymous deal. Sometimes that, sometimes that's helpful. All right, that is 9 minutes down. So thanks for sticking with. Here we go. So slides. That keeps on opening up. So electric fields and electric charges, we did some things with charges and charging last week. A reminder, when we charge objects, we can only transfer charge. You and I aren't going to be able to create a charge out of nowhere. Nothing that we do or interact with will allow us to create a charge out of nothing. Nothing we do will allow us to destroy or remove charges. All we can do is take them and move them from one spot to another. It's just, and there is no why to it. That's just everything we observe shows us that it's not within our ability to do that. The universe doesn't let us do that. So all we can do is transfer charge, remove it from one thing, put it on something else. We've talked about doing it by friction. We've talked about things of those sorts. There's a way to transfer charge by conduction. That works. Induction is a clever thing that we're not going to worry about right now. So the electroscope, I was intending to do this last week and then time got away from me and I didn't have it all lined up. So I'm just going to try to show you that now. It's a really pretty simple system. So I am adjusting, if you can make sure, if you want to see, adjust the screen or make sure that you're looking at the camera. Is this, let me make that, nope, that's not what I wanted to do at all. I just got rid of the camera. Crap. From the recording. Sorry, guys. Let's see. I don't know how to bring that back. Start webcam. There. There's, there we go. Hey, the webcam part is back. All right. So down there, and then I've got, this is just like a little piece of foam, and I normally have a piece of PVC pipe up here with me for, there it is. So the electroscope is a really simple device. Let's see, maybe we'll try to do this, that'll help a little bit. There we go. It's a really simple device. There's just this metal sphere here with a thing going down, and then you can see these two things hanging there. Those are just really thin pieces of metal, kind of like mylar, like a mylar balloon. And then just a PVC pipe and that chunk of foam. So if I would charge by friction, right? So I'm sanding electrons off of one thing and onto the other. So that means one of these has more negatives and one of them has, well, less negatives. The thing that's lost negative charges is now positive. The thing that's gained negative charges is now negative. We don't know what charge this thing is, but if I bring this near, oh, it's not doing anything. What's going on there? I touched it. It was, so when I touched it, then that's conduction. I transfer charge by touch from this to that. Yeah. So now you hopefully saw those two little metal things, those two little metal pieces of like thin aluminum foil almost, but thinner than aluminum foil. They kind of went, whoop, yeah. So they push each other away. And if I go like this and I just touch it, then what ends up happening is any extra charge goes to me and it goes away. So charge by friction, bring it near, and there, I haven't touched it yet. I'm moving it around to try to, I have not yet touched. It might look like I've touched from your perspective, but I haven't touched. And now I'm just charging, I'm being near it. I haven't transferred charges, but I can kind of make charges run away on that metal thing. So I touch it, charge transfer by conduction. So that's the sort of thing. There's a lot of stuff that's done with static electricity, static charges, things like that. So there's the electroscope deal. And we did that by contact either also. And now forces due to fields. Um, so just the heads up, I'm talking about gravitational fields only as a way to kind of link things. You don't need to stress about gravitational fields. And I'm just checking to make sure I'm not getting questions over there. So you don't need to stress out about gravitational fields. I'm just using them as a way to kind of link these things together. But you might remember from semester one, we talked about weight, like when we did the thing where you take an image and you talk about the forces that are on those things. Like the standard was there's a soccer player or a soccer game and there's a soccer ball, and talking about what forces are acting on it, what's all those sorts of things. And within that, we asked about the weight of each of those different things. So to find weight, we took the mass of the object in kilograms, and then you might remember we multiplied, to find that force, we multiplied by G, which is 9.8 newtons per kilogram, or ballpark 10. But that gravitational field of the Earth interacting with us is what pulls us down to the Earth. And gravitational fields are everywhere surrounding an object with mass. They don't require contact. They'll interact without contact. And those gravitational fields interact with masses. Well, electric forces, magnetic forces, those things also do not require contact for there to be a force. And so those are two more examples of forces that must also then have fields. So there is an electric field and a magnetic field. There we go. Oops. So masses produce gravitational fields all around things. So right here, there's not a mass right there, but the gravitational field of the Earth exists there. If I put a pen there and let go, well, it falls down because that gravitational field interacts with that mass. If we talk about charges, it's the same sort of thing. Charges produce electric fields, and those electric fields only interact with other charges. They don't interact due to mass. They don't interact due to magnetic stuff. They interact due to charges. So electric fields are produced by charges and they interact with other charges. Let's see, I think. So there's this simulation. We'll open this bugger up, take a look. It's taking a little bit of time. Getting there. All right. A couple of things that I'm going to add. We'll add electric field. I like the grid. To me, that just is, I don't know, helpful. So right now, this background that you're seeing, just a black background with a grid. Once I put a charge on there, there'll be a bunch of ways, a bunch of things that they do to show us the electric field. So let go. Whoop. Yeah. So now on this simulation, they're showing us two things right now with the electric field. And actually, you know what? I'm going to go backwards a smidge bit. If we make it like this, if I put the negative charge in there, right, then if we did a gravitational field, if we said that this blue thing was like the Earth, then everywhere we're at out here, well, the gravitational field would be pulling objects into the Earth, right? You're above the Earth, the gravitational field is pulling you to the Earth. If you're, for us, we're always above the Earth. Any location you are compared to the Earth, the gravitational field would be pulling you in. So this arrow shows the direction that that gravitational field would pull a mass if this were the Earth. Now, it's not the Earth, it's a negative charge. So we have a kind of slightly different thing to think about. So now this is a negative charge, and these arrows show us the direction something would get pushed or pulled into that charge. Sorry, doing one quick thing. Paste, send. So again, I just sent out the link to the way you can ask anonymous questions if that uh, is something you're concerned about or would like to do. Um, so if you have a question that you'd like to ask, again, you can click on the link that I just sent in the Google Meet, and you can type in your question, check the box for Ask Anonymous. So now, if this negative charge is here, and these arrows show us the direction that an object would get pushed or pulled, um, we kind of get the sense that, hey, the field is strong here. On this simulation, they show it strong by being like a more solid or bright or defined, uh, dark almost, but it's white, arrow. And as we get farther and farther away, the electric field gets weaker, and so this thing gets more faint. Other simulations, instead of making these things darker or lighter, will make these arrows longer. A longer arrow means the field is stronger. These things are called field vector arrows. Um, so on the note sheet, if you have that note sheet, um, that the field vector arrows are on the back side of that. Um, yeah, we'll get there, um, I believe. Why does that keep on stretching out like that? That's annoying. Remember again, you don't have to use this sheet. It's just there as a resource. Sometimes it's nice to have a structure. You definitely don't have to print it out. If you want to just write stuff out, you're good. But on the back of this sheet, we have the electric field vector arrow. And so when we're looking at this simulation, these arrows are the electric field vector arrows. And description, um, it's an arrow that points in the direction of the electric field. That should catch up at some point. There we go. And if we look at this, it's also, if we imagine there to be like a pretend imaginary uh, positive charge, like here, that imaginary positive charge would get pushed this way. So we have this thing that we would call a test charge or an imaginary charge, and those field vectors show the direction in imaginary positive charge would get pushed. Why is that? There it is. Oops. That should be charge would get pushed. Um, and we could say it's either the darker or longer arrow means a stronger field. So for those electric field vectors, that's what we're talking about. All right. So I'll give you a second or two to kind of make note of that. Then I believe test charge is on the front side of this note sheet. So we'll go back there in just a second and make sure you have a spot to put that down. And so I'm hoping that's enough time. And now on the front page, here's test charge. So a test charge is an imaginary positive charge that is really small and does not produce its own field. And the symbol for that, if it's ever written down in different spots, sometimes it's like Q with little subscript 0 or O. Sometimes, oops, don't do that. There you go. Sometimes it's Q with a little subscript T. For test charge. So that's, oops, That's what we've got there. I'm not seeing any questions or comments or uh, anything that looks like you're freaking out or you're having a trouble keeping up. So I'm going to continue on. Um, so if we're looking at like examples for a negative charge, the arrows point in towards it. So like an imaginary positive charge here would get pushed towards the negative charge. So the field is towards negatives. If we look at a positive charge, well, if we put an imaginary positive charge here, it would get pushed away from this red positive charge. So if there is a positive charge, the electric field goes away from a positive charge and it goes towards a negative charge. Now, we believe fields exist. We have all sorts of evidence that field exists. Nothing proves that they don't exist. There's no anti-field proof. There's no existence of any proof that fields don't exist. There is a lot of proof that fields do exist. Now, the thing that we did make up, and any scientist should kind of agree with this statement, the part that we did make up was to say the field is towards a negative and away from a positive. We needed a way to kind of describe what's going on, and we said, well, if we imagine a pretend little positive charge here, we could describe the direction based on what a pretend positive charge does. So we made up like the directional part, but it's something that's kind of accepted the world over. So there you go. Come on, clicky, clicky. There we go. And now 5 minutes left, and we're on to the start of the actual assignment. So again, 60 minutes for class period each day is about what we're hoping for. Um, that's my goal for all of us. This electric field hockey thing this is the assignment that I believe actually I really think it can be a fun thing if you let yourself have fun. Um, so it takes a little bit for it to load. Actually, this is one that takes a long time to load. So the most frustrating part, the thing that sucks the most about this is how long it takes that simulation to load, because it was made quite some time ago, and it used to use Java, and they didn't rewrite the whole thing because computers nowadays don't use Java. So instead of rewriting it, they found some company that does conversions from Java to like HTML5, which is an accepted way for things to run these days. So it takes a long time for this to convert uh, online from Java to what we can do. And what I have found is that if I go to another page, another tab, and wait and think, hey, I'll just come back in a couple minutes, that doesn't work. I think, I'm not sure, but I think it only works on getting it running if you're on the tab while it's trying to convert. And we're still waiting. Okay, we're getting close. Here we go. All right. So a couple of things. Make sure you do go down on the bottom down here. And you know what? I'm going to try to change the mouse view to kind of emphasize some things. So down here, there's trace and field. And I'm going to click on both of those, trace and field. Oops, come on, there we go. Okay, so now this puck is kind of like a test charge. We imagine it to have, it doesn't create any electric field on its own, but it will be affected by other charges. These charges up here are charges that we use to make this thing move, and we're just going to try to score a goal. We want this to go in this goal over here. Down here you see there's practice, difficulty 1, 2, 3. And if I want to score a goal, well, this is a positive charge. One way to score a goal is to just put a negative charge right here. And as soon as I do that, we see that the simulation adds all of these little arrows. And the darker the arrow, and again, those are electric field vector arrows. So these electric field vector arrows show us what happens to the field in these areas. and we see that it's a stronger field near this charge and weaker away from that charge. And remember, we're thinking of this as being like a test charge that doesn't produce its own field, which is an imaginary thing. So now if this is lined up and I'm ready to go, I hit start, and by checking field, that's what puts these arrows on there. Checking trace, we'll see a little dashed line that shows the path it takes. I hit start, and because we've got so much going on and things are a bit slow, let's see if I close that bugger down, if that helps. Ooh, doggy, that is a slow one. It's usually not quite that slow, but you can start to see now that these, it's kind of putting these little traces on there to show us the path that this charge has is taking on its way to score a goal. And then when we're done with practice, the assignment is do this, and when you have a goal, screenshot it, paste it in your assignment. And oh boy, it's usually faster than that, but you know, hey, things are what they are. I wonder if I close that. Hey, goal. And it sometimes makes a little noise. Don't know if you heard that or not. So we've got that. And now the assignment for today is to go through and do that. It's 11:30. If you got to run, you got to run. I just want to make sure I clear up what the expectations for the assignment are. So if you have to go, you can hang up. I'm perfectly fine being hung up on. That's not a big deal for me. If you got to go, you got to go. But I just want to make sure for those of you that have a minute, we'll just make sure that we're able to see how this assignment works. So in classwork, the electric field hockey thing, you should each be getting your own image of this, or your own version of this file, pardon me. Um, a smart guy would have known to have that loaded ahead of time. Usually I don't have this many issues with the internet speed. Thanks for your patience, folks. So what we're basically going through and doing is like in the practice shot, you go through, you get your goal, you do a screenshot, paste it here. Difficulty 1, the next one is go to difficulty 1 and do a screenshot and post there. So difficulty 1, I go to the simulation, and then down here, down on the bottom is difficulty 1, or is difficulty, and then there's 1 and 2 and 3. So I'm going to go to difficulty 1, reset, go to difficulty 1, and now it's going to take some time to get everything lined up, right? So we're going to have to go through and kind of plan some stuff out. So here, it can't hit this beam. We need to have it go around and score a goal. So I'm going to try putting a positive charge here. Well, I'm going to try to put a positive charge there. Come on. There we go. Okay, so now it's starting to go. Give me a couple. And so these positive charges will push it. Well, there's these two arrows kind of showing it'll get pushed down like this. But I don't want, if that's all I have, it'll just go down here. This will pull it towards a little bit. You can kind of see the direction of the field and which way it's going to go. I wonder, maybe I go way down like that. And then I can try to pull that bugger in, and you can see down here, usually, where did it go? There's a spot charges 5. So I've got 5 charges on there to see what happens. I'm just going to hit start and we'll see what happens. Start. I doubt I'll make it on this first attempt. It's worth just kind of seeing where we're at. And again, if you need to go, you need to go. You can hang up. That's perfectly fine. It looks like we're going to miss by quite a bit here, right? It'll still end up getting kind of pulled up, but it looks like it'll get pulled up a little bit late. Once we have this as a goal, you do a screenshot of this and you put that in here. Just paste it in there, and then when you're done, you turn it in. So that's all there is to it. I'm missing by a lot, and this is going really slow. So I'm just going to hit reset, send that back. I'm going to put this over here. Maybe I go 2 over here. We'll try that. Start. And then in the past, not doing it today, but in the past, we've also done things where we've said, hey, like whoever does it with the fewest number of charges, yay for you. But it's it's an awkward thing to keep track of that stuff online. Oh, come on, yeah, not quite. Oh! So that's the sort of thing that we're looking for, right? So now I could look at putting just I can just load this bugger up with negative charges to pull that positive charge in, reset. If you want to clear everything out, there's the clear button. There you go. But that's the idea. And if you score a goal, screenshot, paste that bugger in. And that's the work for today. That's pretty much all I've got for you, folks. Well, and that didn't do it. Sometimes it'll swing around and get in there on the flippity flop. Blast. Okay, that's all I've got for you, folks. So if that was a goal, I would do a new screenshot here. Bloop. If that were a goal, come on. I would do a quick screenshot of this thing, and I would do a quick screenshot of that, and copy, and then I would just put that in here. That wasn't a goal, but there you go. Have a good one. See you guys later.